Good evening. Today we are going to solve or we can say analyze determinate beams by Macaulay's method. So when we will say analysis of determinate beams, generally we have deformations required in that case. So now deformations, we have slope and deflection, that is linear displacement I can say. And then methods we have available for this slope and deflection. We have four methods which are mainly used are Macaulay's method, conjugate beam method, moment area method, and Castigliano's first theorem, which is known as strain energy theorem. So now we will go today, that is Macaulay's method. Now this method is used to determine slope and deflection in determinate structures. Using this method, we can find the slope and deflection at any point in the member. Now, what is main disadvantage of this Macaulay's method? So this method is applicable only when my value of EI that is constant throughout this span. So if EI is constant, then only we can apply. If EI is changing, we cannot apply this. So now in this Macaulay's method, we have to use this equation EI d2I by dx square, that is equal to m, that is bending moment. Now if we integrate this equation, so by integrating this equation, I will get it as EI dy by dx equal to integration m, because integration of d2I by dx square, we will get it as dy by dx, and this is equation of slope. This is equation of bending moment. If I will go EI d cube y by dx cube, that will be equation of shear force. And if EI d4y by dx4, that will be equation of intensity of loading. So we are in this way, we are going to integrate one by one, and we are this equation EI dy by dx for slope. Now again, if we will integrate it, then by integrating we will get EIy, that is double integration of m, and this will gives me equation that is for deflection. So we have to use only these three equations to solve the problems by using Macaulay's method. Now, equation of bending moment for simply supported beam with concentrated loads. I have considered concentrated load, then considered UDL, and likewise we have these equations. How to form these equations by using Macaulay's method. So let us, we have number of concentrated load acting on this. Now, if you are writing equation of bending moment from left support, then you have to consider x that is in last region. Now how we are going to decide the region? Where my bending moment equation changes, I have to change the region. So now you can see here, if I will mention this point is as C, so till C I have equation that is of bending moment, we have only RA. So we have first region is from A to C. Now if we will go from C to D, then you can see what will be my equation. So it involves RA as well as W1. So this will be my second region from C to D. Now if we will go from D to E, then we have bending moment equation involves RA, W1, W2. So your bending moment equation is changing, then your region will be changed. And last region we have between E to B, and in that region you have to consider X. And then we have to write simple bending moment at XX. So what bending moment we will get it as? So RA into X, that is RA multiplied by X clockwise, so plus minus, because anti-clockwise, W1 into this distance. Now we have total, we have this as X, and we have to subtract L1, so minus WX minus L1. Now here we have first compartment, then we have, this will be my second compartment, then we have, this will be my third compartment, and then this will be last. What does it mean? That means if you will consider first compartment, your bending moment equation will this. If you will consider second compartment, then your bending moment will be this one. Not only W1x minus L1, you have this portion of bending moment. If you have third, means between D to E, then my bending moment equation will be this. So you have to consider all the part or all the terms which are left of it, and then likewise we have to consider when we will go for integration and all this. So now if I will write equation for bending moment, but we are with UDL. Now this is most important. So now in Macaulay's method, UDL should be till one of the end, and if we do not have, then we have to provide dummy UDL of the same intensity in both direction. that is downward also and upward also. That is because if we have equal and opposite, then that will not affect our original problem, and therefore we have to apply in both direction, and then only we can write the equation, write the terms for UDL for general equation. If UDL is still left hand, then we can write equation from right hand. We need not require to apply any dummy UDL. Or if your UDL is still right hand, then we can write equation from left hand. We need not require to write apply any dummy UDL, because this dummy UDL plays very important role when we are going to say slope and deflection by using Macaulay's method. Now we have this problem, and we are interested to write down here again. UDL is still left hand, so I can write equation from right hand, and this will be simple. Then we have first, that will be region between B2. So I will mention this as C, B to C, because till B to C we have only RB into distance, that will be bending moment. But if you will see from C to A, then you have RB also and UDL also. So what will be my equation? So as UDL is still left hand, we have to consider equation from right hand. Now again, where we have changed the bending moment equation, I have to write down compartment. So this is my first compartment between B to C, and from C to A, I have this as another compartment. And likewise, we can have this equation. Now, if for this we are interested to write down equation from left hand, then UDL should be till right hand. As UDL is till middle, so that we have to apply dummy load till right hand in downward direction as well as in upward direction. Now you can refer this figure. So we have applied this 40 kilonewton per meter, same intensity, whatever intensity we have, same we have to use. Then only we can write general equation. Because now if we will consider this, and if you are going to write down the equation from left hand, then what equation you will get it as? So we are going to get EI d2y by dx square. And then it becomes difficult, because if you write equation, then you have in first compartment, that is between A to C, we have considered C over here, and then we have this equation that is equal to RA into X minus WX square by 2. But when we will go that for second compartment, then we already seen my left portion I have to use as it is, but we cannot use it, because my UDL is till, and till this if I have to use, then my UDL should be till this. But if you will go to this portion, then you have X, if you have first in this region, so I have say this X, then I have this equation, RAX minus WX square by 2. Now if you have till this region, then also your this portion will be as it is. There is no change, because now UDL I have in X portion. So my value of reaction RA into X minus W, that is 40 into X square by 2. And then next term will be here, which will be plus. And now I have to go for this W. And now what will be value of distance? So this will be X and this will be 4. So we have X minus 4 square by 2. So to write general equation, you should have term dummy load till other end. And then you can see over here, so we have this will be X, and then only we can write this as RAX minus 40X square by 2, and then we can have this will be minus 40X minus 4, and that will be equal to, so this will be my first compartment. And then I have this will be second compartment. If I do not have UDL throughout, then my equation will not be minus 40x square till end, and therefore we have to apply dummy load, and that will be till other end. So if we will go to this problem, and then what will happen in this case, we have to apply dummy load likewise. So I have three regions now. I have first region, this will be RA into X. Then I have second region, then C to D I have second region, where RA into X minus 40X square. And then I have third region, D to B, which will be plus 40X minus 5 square by 2. You can see this. So we have compartments. This will be my first compartment, equation changes. This will be second compartment. Though in that case, second compartment I have to use both these terms, 1, 2. And in third compartment, we have to use all these three terms. So likewise, we have to go for UDL. Now, if we have couple, then what will happen in this case? So now if we will go for this couple, I will write it. Then I have RA into X. This will be my first region. So I will mention this as C. So RA into X, that will be between A to C. So I have this first region plus m into x minus L1 to the power 0. This plays very important role. Value of this term that we have 1 means m only. But why we will go for to the power 0? If I will not consider to the power 0, so if I will write only m, then that will show it will be in the first compartment. Now, how you can see this? So integrating equation, I will get mx minus L1. Integrating above equation, so I will get in this fashion. So we have this will be first compartment. So I have this will be first compartment. Sorry, till 7. Your constant of integrations are always in first compartment, not in the second compartment, because these are always there. So now you can see here, I have explained over here, wrong way of writing equation. So if I will write in this fashion, ei d2i by dx square equal to m rax plus m. So is it wrong? Yes. Because when you integrate it, for a moment it is okay. But when you integrate it, what will happen? So your equation becomes in this fashion. So actually I have first compartment in this one only. Because x is always in first compartment. But as you have mx, so this x will indicate you are in first compartment. And to avoid it, we have to use that x. Because if I will not use here x minus L1, so what happens in your equation of slope? It becomes mx instead of x minus L1. And so x minus L1, what it indicates? It indicates it is in second compartment because x is in first compartment, and whenever you have bracket, that will goes to second compartment, and therefore you have to always write whatever second compartment or distance of the first compartment, you have to subtract from m, and then you have to write it power. Otherwise we are going to get wrong equations over there. You can see in last slide what equations we have, x minus L1 square by 2. But if you have not taken this x minus L1 to the power 0, your equation is totally wrong. And once I have with these three concepts in Macaulay's method, then my Macaulay's method is very simple to analyze determinate beams. Now we have some problems, I will go through it, and then you are in position to solve any problem. So simple problem I have taken, that is concentrated load P, that is at left hand, and then we are considered from right part. Why we have considered from right part? In that case I did not require to find reactions. If I have to find from left part, then I have to find this reaction, then I have to find out this moment also, and then we have to go for this. So if you will consider from this, then your constant of integration is 0. If you will come from right, then your constant of integration are there. But why I will prefer from right? Because if your reaction is wrong, then everything will be wrong. So in this case, your reactions are not included in the equation. So better from right side. Then what will be my equation? P into x, minus sign because clockwise right side. Then we have to integrate it. So what will be integration? So minus px square by 2 plus 7. We have only one compartment because we have bending moment equation throughout the span as minus p into x. Then we are integrating above equation. So we are going to get another constant of integration. And then by using boundary conditions, going to be determine C1 and C2. That is constant of integrations. Now we know at fixed end, we have slope also 0, we have deflection is also 0. So we have dy by dx 0, we have y 0. We will substitute this in these equations, and by substituting this, we will get value of C1 equal to PL square by 2. If I will put x equal to L in equation of y, then I am going to get value of C2, that is minus PL cube by 3. And then I will put these equations. So I will have this equation, that is minus px square by 2 plus PL square. So equation, if I will write here, so my equation that becomes EI. So we have this will be C2. So in equation of slope, if we will go to the equation of slope, then what is equation of slope? Minus px square by 2 plus 7. So 7 we will put over here, and equation of deflection, we have minus px cube by 6 plus c1x plus c2. So here we will have first equation, that is for slope, minus px square by 2 plus pl square by 2. If I have to find out at b, because we have written slope from b, so we have, that will be value as PL square upon 2EI. So this is my value, because x0, then you are going to get this term as 0. And if you are going to get it as plus, so this is your clockwise. We are coming from right. So right, we are going to get it plus clockwise, that value we are going to get. Deflection at B, we have to substitute 0. Now we have, this will be my equation of slope. Deflection. Now I have this term 0, because x0, we have, this will be 0. And we are going to get this value as minus PL cube upon 3I, minus shows it is in downward direction. So if I will go with UDL, then I will go a little bit fast over here. So my equation will be minus WX square by 2. Now in the same fashion, you have to find out value of C1 and value of C2. So just integrated the equations, and we are going to be in this fashion. By substituting your boundary conditions, we are going to get C1 WL by 6, and value of C2 we are going to get that value as minus WL4 to the WL4 by 8. And then we have equations. We have, this will be equation for slope. Put x equal to 0, you will get slope at B, and put x equal to 0, you will get deflection at B in deflection equation. Minus is in downward direction. So similarly, we can have for couple also. Now we have here, that is one compartment only. So I can directly go with m minus mx to the power 0. Here you write or do not write, but be habitual. Write down always power whenever you have any term with m. And then we have, this will be mx to the power 0, integrate mx plus c1, integrating mx square by 2 plus c1x plus c2. And then we have again boundary condition in this fashion. C1 is ml, and C2 we are going to get as ml into L. That is C2 we will get minus ml square by 2, because this is ml square, which will be plus, and this will be minus ml square by 2. So plus ml square by 2 on right side, and other side when it goes, it becomes minus. And then put x equal to 0, you will get theta b ml upon ei, and for deflection you will get it as minus ml square upon 2 ei. Now, if we will go for simple support, these cases I have considered, because these cases values you have to remember. So for cantilever beam, concentrated load, cantilever beam, UDL, cantilever beam, couple, simply supported beam with concentrated load. Now here I will get it as RA, RB, and values if we will see, we are going to get as P by 2, because we are symmetrical. What will be equation? Then we are going to be with two compartments. First compartment, which will be between A to C, I will mention it as C. So A to C, I will be with P by 2, my X, and minus. So this will be X we have considered here. And now here we will get it as P by 2 into X. We have there minus, due to this P, X into L by 2. So X minus L by 2. So we have, this will be equation. Now we have to integrate it. So we will integrate it. By integrating, first we have equation of slope. By integrating, we have equation of deflection. Now we have simple support. So in simple support, we have boundary conditions, that is deflection at left support is 0, deflection at right support is 0. At both support, our deflection is 0. So we will substitute this first, which is at support A, then my value of C2 is 0. So you can see over here, if you will put x0, then you have this term 0, then you have this term 0, then 0 minus L by 2. So always keep in mind, when we are going to say x0, x0, A is in first compartment, and we have first compartment till here and here only. So whenever I will write equation for first compartment, I have to consider values of first compartment only. Or I can say, if I will put value x0, then what I will get? 0 minus L by 2. So whenever bracket value you have minus, you have to neglect that compartment. So you do not say 0 minus L by 2 minus L by 2 and then power of this. No. Because here if you will see 0 minus L by 2, so minus L by 2, and you will say power will be, square will be plus. No. My value of the bracket, I will say, if I will write 0 minus L by 2, then that is minus L by 2. So whenever I have bracket minus, that compartment will not be there in the equation when you will put your boundary conditions, or when you are going to find out slope or deflection at any point. And then we have C20. So now once I have C20, I will put at x equal to L support B, where y is equal to 0. Now here all terms will come because that is in your last compartment, and you will get C1 equal to minus PL square by 16. So we will put C1 minus PL square by 16 in equation of deflection. So if we will put it in this equation, and now we are interested to find out equation of slope and deflection. So by substituting value of C1 in case of slope, because in slope we have only C1, so we have substituted C1 over there, and here we have C1, and here we have C1 and C2, but my value of C2 is 0, so that becomes 0. In deflection we have C1, C2, and in slope we have only C1. Now, if we have to find out slope, we have to put the value of x equal to 0. So when we have 0, x equal to 0, so we have again only first compartment. So I have to consider first compartment. So this term will not be there. So we have this term again, x equal to 0 becomes 0, and my value of theta is minus PL square by 16. So this is again clockwise because we are coming from right side. So that slope sign convention plays important role. So we have theta a, that will be minus PL square upon 16 EI. So we have x equal to L in the equation of slope. Then we are going to get slope at B. Now here you can see we have to put x equal to L. So we have all these terms. So here we have L square. So we have L square by 2, and here L minus L by 2. Now this L minus L by 2, we have bracket as plus L by 2. And then we have to consider it. Here also we will get value that is PL square by 16. But this we have on at B, and then we are this value that is anti-clockwise, because we have this value here minus, so we have clockwise because we are coming from left, and plus we have anti-clockwise. That is as per your Macaulay's. So now deflection at center, if we have to find out, we have to put x equal to L by 2. Now you can see in this second compartment. So again we have this will be first compartment. And now if we will go to this, then L by 2 minus L by 2, it becomes 0. So we have only first two terms gives me minus PL cube upon 48, which will shows it is in downward direction, minus sign. Now we will go with UDL. I will just show you first. So we have RA RB WL by 2. Then we have this equation. Same way, no change, we have this one. So we have this will be here we have only first compartment, only one compartment, because we have Van moment equation as one only. So we have all the terms that comes in your first compartment only. So C1 you can write after this also, that is no issue. And then we can have x equal to 0, 0, C2 we have 0, and then x equal to L we have C1 minus WL cube by 24. And then put in the equation that is of dy by dx and y, and then find the slope. When you will put at x equal to 0 minus WL cube by 24, so that is clockwise, and at B we have plus, which is anti-clockwise. And if we will find deflection at center, that comes minus WL 4 upon 384 here, minus again shows it is in downward direction. So one problem we will go, and then we will stop for this Macaulay's. So now let us, we have this problem. I have a number of problems, but we will not go for that one, because then the length of the lecture or time duration of the lecture becomes larger one. So, and you will get bored for it. So now we will have this, then we have calculated reactions over here, and then we will write equation. So now we have to go again last compartment, that is C to D. Then we have this will be minus RD. So these values we have calculated for reaction, and we got RD is 25.56. So automatically Fy0 RA we will get it as 4.4. And now we have to write down the equation. Now we should be very careful. So we have in first compartment, if I will see from A to B, I have 4.4 into X. If I will go from B to C, then 4.4 into X will be as it is. And then we have this will be plus 25, and that will be X minus 2 to the power 0. That is again most important one. And then we have third one, where we have to consider that is term, which is minus 30 into X minus 3. So you can see this equation. So compartment that actually plays very important role. So I have this will be my first compartment, then I have this will be my second compartment. So for A to B, I have to use only equation, that is first term. For B to C, I have to use first plus second term, and for C to D, I have to use plus first, second, and third term. Then once we have in position to write down the equation, then things are very simple. So just integrate it, C1 constant of integration. Then again I can say this will be my first compartment. Then I can go with second compartment, and then we can have third compartment. Integrate again. So now again, your constant of integration are always in first compartment, and then we are over here. So we have this will be in this position. So likewise, we have to go for the integrations, and then as we have simple support at both supports we have 0. So in simply supported generally C2 we have 0, and then we have to find C1 we have minus 28.6, and then we have to put over here. So this is my first compartment. So then this is my second compartment. Here you can have this will be your first compartment, and then you have this will be second compartment. So when we have x equal to 0, we have to use first compartment only, and then therefore my value of C1 becomes 0. So now we will go for this equation of deflection. We have in this fashion, and then where you have to find out values, you can find it at theta a. We have minus 28.6 upon a clockwise, and if we will this bracket negative value, then neglect this term, and the equation becomes. Now we have to find slope at B. Slope at B means we have that is second compartment, because first compartment we have value as 1, and then we have this will be my second compartment. So now if I have x equal to 2, if I will put 2 minus 3, this becomes minus 1. So we have to neglect this bracket, and then we have theta b minus 19.72 upon e. At C, then we have this 3 minus 3 becomes 0. So we have only these terms, and we will get this value 5.28 upon e. Now this get plus means now it goes to anti-clockwise. So my slope is going to change from clockwise to anti-clockwise, and then at B we have 45.11 upon EI. Now deflection also you can find at any point. So this is calculated at B. So again you can see this we have actually this is 2 minus 2 0, because at B we have, so third term we have not considered because that comes 2 minus 3 minus 1, so we have neglected it. And then we have minus 37.8 upon here, that is in downward direction at x equal to 3. Then that also we have not considered because that 3 minus 3 becomes 0, so need not require to consider third term. And likewise I will get value of yc0. So we have problems, many problems we have over here, but we will not go for these problems. So thank you. So today we will stop for Macaulay's. In this way, you can practice the problem. If you have any doubt, you can call me. You have always, if you are a subscriber of this, or if you are going to see these videos, then you are with my mobile number, my email ID. You can contact me on mobile or on email ID, and you are going to get question answer of your questions. So thank you. Good night.